So I received my Genmitsu 3020 Pro Max router close to a month ago now, but it took over a month to get it from China. So the project that I was getting it for, I wasn't done with, and I had other stuff. So I'm just now finally getting to assemble this, but thought I would do an unboxing video. And you can see that it didn't get from China in the best of shape. Got a few dings on the box, but hopefully the contents are still in good shape. So, with that, let's open up and see what we got. And so on top, we have our manual. And we have a set of labels for all of the axes. So we'll put those out of the way. And take our first peek inside. And so what we have is power supply, a bunch of cables, and a few bits and memory, and the spindle, and then the body there. I should be able to pull this whole thing off. Well, part of it anyway. Some of it, it's just a spacer, so now we have what's left, which again, all the different cables that fell out, set of hardware, and we will take a gander at the manual and see what the first steps are, but the first step is probably pull that out, and then we'll go from there. So the manual's not bad, showing specifications, and then we get into the list of parts. And the different accessories you can get, including the laser. And I may actually take the laser off of this unit that I have and stick it on here. We'll have to see if that'll work. And so here we go for assembly. So we'll start pulling things out and see what we can do. So after pulling all the various bits out and the vertical component, then we get the base. And so now we can take and pull the base out and start the assembly. So the first assembly step is to find this bag of what they're referring to as T-nuts, although they aren't T-shaped. There's a special way to put these in now. But these are spring-loaded T-nuts. See the little ball with a spring in them. And those are so that they actually will stay fixed in the rail when you go and you slide them in. And there's a reasonably good assembly direction here. You've got the illustration. You've got pictures of where they want them all. And then a step-by-step diagram for how to actually get them to go into the rail. So after I get 16 of these in place, we'll go from there. And basically, these are a bit of a joke because they essentially just fall right into the rail. The spring isn't doing anything. So you just pick it up and, whoops, backwards. Sorry, I know you can't see that. Yeah, they just kind of fall into place. The spring, and they fall right back out. So the spring is not doing anything, which is kind of good because I've got ones that don't have the spring in them. So we'll get the rest of these in and start assembling the next layer. So a couple of these actually did what they were supposed to and had enough spring tension to hold them in place. But as you can see, most of these are really just kind of worthless as far as the spring part is concerned. I don't know for sure if that's because they've got this little slot down the middle of the rail, if it's that the slot shouldn't be there and that's why they aren't working, or if these just need to be deeper. I did note some of them, there was a little dimple here where they had drilled the hole for the spring a little deep. So as you might expect, the next step is to install the body on top, and using these M5 by 16 screws, and you are directed to space these so that they're 20 millimeters apart, and rather than having to get a ruler out, I'm just putting this above it, and then I can look at it and keep my fingers out of the way. Simply move these over. Now, of course, the challenge here is that. So, not exactly the installation experience I'm sure they intended, but we will get this bolted down and come back. So the good news is that despite the problem with the springs not actually keeping the T-nuts in tension, these actually screwed in quite easily. Just as long as you got them lined up, they catch the screw and thread in pretty well. I had a couple that the threads weren't quite clean, and I had to back them and redo them a little bit, but this so far are just hand tight. Now I get to push it to the back and tighten it all up. So the requirement here is that the back of the gantry be 13 millimeters from the back of the machine, which is a little problematic to measure easily, but that's approximately half an inch, and a USB stick is just under that, so that's probably more like 12 millimeters. But you can actually use the USB stick that came with it as something of a judge for exactly how far away you want to be. So, one little gimmick. It'd be nice if they actually provided a tool that had that. So the next step is to install the rubber feet on the base. Well, mine already came with the feet installed, which is great, except for the fact that it means that I couldn't actually do the previous step correctly. The plan is designed to be having this base sitting flat on a hard surface, hard, smooth, flat surface, and then when you would set this part down on top of it, it would sit flat on the surface, and first off, all the screws would have gone straight in, and instead of what I had to do, which actually hold this up in order to get the screws aligned, and it would be square. I didn't have that, and I probably should have just gone ahead and taken the feet off, but I ended up putting some spacers in there so that I could get the base of the vertical aligned with the rail. The other thing I did was to go ahead and manually move the deck all the way back to judge my 13 millimeter distance, which is probably more like 12 on my setup. And as you can see, we are past the edge of the grid and mounting structure, although we aren't completely off the table. I'm going to go ahead and pull it forward and see where that takes me. Now, with the deck all the way forward up against the mechanical hard stops, you can see that we're pretty much in the same spot. We are actually off the bed a little bit, so if I wanted to make the best possible use of this bed, I should probably move these forward even more. Given at the moment, I'm not worried about trying to maximize. I can always adjust that later. So I'm not going to stop at this point and make that adjustment. And the limit switches are going to take a little bit out of this range of motion as well. So until I get the limit switches on and see where they are and how they adjust, I'm not going to worry about the mechanical. Alright, so for the next step, we're installing the limit switches to the bottom of the bed and to this point here for the Z-axis. And using these M2.5 screws, you've got 10 millimeter and 12 millimeter. And I'm not sure what the nuts are for, although I do have 2 extra of the shorter ones. And then we're using the switches. So 3-pack in the bag. I'm not sure what the optional Z-limit switch is. Let's see if we come across that later. Alright, so I now have the limit switches installed. When I originally looked at the picture in here, I thought it was showing that this limit switch was mounting to the plate, but it actually mounts to this little bracket underneath, which is cleaner. And so the contact point is underneath the plate on the mounting block. And I went ahead and installed the emergency shutoff switch, which is shown in every picture, but there's actually no instructions for installing it. So I went ahead and installed that. And so now I have each of these in place where I can test. You can hear it click. And I noticed there's where that second Z-axis limit switch would be the optional one for the bottom side. And so I'm going to go ahead and install that as well. So there's your top limit, basically a homing sensor. And then this will probably take a little bit. Anytime now. That block is quite a ways underneath. This is getting tiring. There it is. Okay, and so that's the limit of our range. And so if we go back up here and try to judge where that's at, it's right at the edge of the table. So not going to gain a lot by moving where the vertical is. So now we know what those extra 2 screws were for, mounting bottom Z limit. And so that works. And so now our next step is to come in and install the control board, which you find in this anti-static package. And using these nuts, we mount it to the back of the rail system. So we'll get that installed and come back. Now, their instructions say to insert the T-nut into the Y-axis profile, then put the control board and the line it to the nut and all of that, which is a tricky and fiddly process, but there's a much simpler way to deal with T-nuts. You just barely thread it on so that it stays there, and you've got to make sure that they're all horizontal, and then you just go up to the rail system and you push it on, and then when you go to actually attach, if I can keep my thumb out of the way, when you go to actually attach, you just make sure that you're pushing it in, and then the T-nut will rotate and latch once it gets tight enough. And this is not something to do one-handed while trying to hold your phone as a camera. So let me come back to this in a moment. Now, the most observant among you may have noticed that I actually had put this on upside down from what they're saying to do in the manual when I first started to demonstrate. And I wanted to come in here and show you exactly how these T-nuts work in case you're not familiar with them. So once I start tightening down to a certain point, then it gets tight enough and that nut rotates into place. And then as I keep tightening, it locks. So that's all you're looking for, is just to make sure that that's far enough in that it can rotate. So if it's too tight, then it won't be able to rotate and lock, but then you want to be pushing in and it will rotate in as you tighten and lock into place. So that's the magic of a T-nut. So the final step of the mechanical assembly is to simply install the spindle motor. Now, I'm not 100% sure what this little nice cushioned plastic piece is. It almost looks like it's something that's designed to clamp in, and it may be for clamping in things like the laser. And actually, I'm pretty sure that's what it is. So the question is, would it fit this laser? No. So that may blow my plan for being able to use this laser, is that this heat sink is bigger than that mount. And given that that's the only mounting you've got, pretty sure that's what that's for, is that's for mounting the laser. So we will just put that to the side and make sure we don't lose it. And so in this case, all we're really looking to do is to keep the wires out of the way, which unfortunately I'm going to have to pause and do this manually. Oh, there we go. Slide that on down in and clamp it. Now the interesting thing with this is that you've got this little kind of rinky-dink fan on the surface that actually will be spinning with the motor. So that's actually not, it's safe enough because it's spinning clear, but you know, when it comes to typical safety requirements, this probably wouldn't pass something like an OSHA check. But for the hobbyist, if you're realizing that this is a power tool and you got to be careful with it, it should be okay. And so with that, our mechanical assembly is done, and it should look something like that picture, except I have all the things moved over to the limits. And so now we move on to the electrical assembly. There's a little documentation on mounting things, but the electrical assembly is simply plug a bunch of stuff in, and we will see if it actually gives us step by step. Moderately, yep. So you've got picture guides, and I'm probably going to do these relatively rapidly and come back to it. I wanted to see if this will focus on this well enough. What you can see is you've got, sorry, it's jumpy. You've got X limits, you've got Y limits, and you've got Z limits. And it's saying to use the first, and the amusing thing is it says there's a spare Z limit switch for replacement. Well, it's actually the opposite Z limit. So they either decided they didn't need it or had problems with it or whatever, but I'm going to hook it up and see what happens. Okay, so I had to show the extension cable for the spindle because this is a pretty neat little connector. Basically, you just push down on it and you see that it releases the clamp. And so you've got these on either side. And so this is what you're going to use to attach to the spindle here and be able to extend it so that it can go back to these connections and be able to run this. And of course, wire handling on all of this is a bit messy. They, at the last phase, talk about putting the coil on things, which we will definitely want to do. Whoops. We'll definitely want to put this on the parts that are moving, which implies that I want to take both of these limit switches and be sure that I route them up and over so that they can be bundled together along with the power line. But for all the rest of this, I'm probably just going to tie wrap it into as small loops as I can. So the installation instructions say after finishing all the wiring, use the cable protector to wrap the cable together and then cut off the excess wrap. Well, and you look at the picture, they're bundling all of the stepper motors together. The main thing, though, that you want to protect is the part that's going to be moving. So that's this carriage that has the two limit switches and then the motor. Now I was bundling this in and I said, wait a minute, this motor's going to move up and down between the two limit switches, so I can't bundle this in. Plus, if I want to swap to the laser, I need to be able to disconnect, so I want to go ahead and leave this connector free. Now I may put a piece on here just to protect, but we will see. But I went ahead and I put a piece there so that, you know, if there's any rubbing, this going up and down won't ever hit that. And then you gradually just bundle all the pieces together as you come back, and you will save yourself a lot of effort if you go ahead and you just leave the ends loose on everything. Don't plug it all in and then try to bundle it, because you have to take the whole bundle and go around with this spiral stuff. Here, you just can go around it easily enough. I mean, I can do it one-handed more or less here. And you just are essentially braiding the cables together. Now, one thing, and I wish they would kind of outlaw this stuff, they used individual wires instead of using ribbon cable for this. And the frustrating thing about it is, of course, that they're all loose. And it's not just that they're loose, but the fact that, yeah, it's messy. But even if I bundle it together, the problem is in this cable, I've got where these wires have moved around. And so I essentially have an EMC problem, an electromagnetic compatibility issue, where because there's big gaps between where these wires are, or can be, they can radiate a lot more when this thing's moving and cause interference with radio and other things. And potentially even with the sensor, with the limit switches themselves. So I really would prefer that they put in ribbon cable style, and it's not worth replacing them right now, but if I have problems, that's what I'll do. The other thing I'm a little disappointed in is, so they have this power supply that they've got a little plastic cover on with the power going in, but it's just a pigtail. There's no place to mount this power supply and no instructions for mounting it. There are some mounting holes, but you'd have to have through holes somewhere on the body to be able to mount up the power supply. So this power supply is essentially just going to sit there loose, and don't particularly like that, but doesn't seem to be any option. I may come up with something that'll let me mount it to the rails up here, but that's for a later date. So I wanted to just show this before I plugged everything in, and then I'll dress the rest of these. I may put a little bit of spiral on it just to bundle up over the distance that they're covering, but I think for most of this I'm going to just tie wrap it in loops. Okay, so we now have done everything that the user manual says to do up to installing the software. And I had just enough material. I wanted to protect this wire for the limit switch, so it's there, and I also didn't want it routed across the front where I had it before. I might actually put a tie wrap just to hold that down, I think. And of course this is bundled together. And so most of the structure then for the part that's going to be moving is actually coming off of the power leads that are nice and hefty. And then I've got this bundle coming up and pulled the limit line out a little early versus the other. And I might try to route this, tie wrap it over here just so it stays off from in front of the fan. Possibly similarly for these others. And then coming off of the limit switch to the motor, and then I went ahead and I brought the emergency switch into that bundle, and that all comes out and goes there. So a nice big maze of wires, but for the most part relatively well protected now. Now, the one other thing that I realized that's a little disappointing is you've got a power switch here, which of course I'm going to have to finagle these to get easy access to it. But this is on the DC side. There's no power switch on the power supply. So you're going to be drawing AC power all the time and wasting that power, because this power supply will always be on even though it'll be low load. It's still, you know, if it's 85% efficient, then it's still taking 15% of the power just sitting there probably. So anyway, so one thing that wasn't in the manual was the contents of this little box, which is this control panel. And it has a little instruction, but not necessarily for this printer, and no detail about how to hook it up, just what the controls are. And it's not too hard to figure out where to plug it into the control board, if I can get back here and let you see. Down underneath there. And so this actually has an SD card. And if I could get it out, you would see it's actually an adapter with a little mini SD in there, micro SD. And so that gives you manual control. The other thing that's not in there is any detail on this, which is the sensor. It's a contact sensor for setting height by probing, and when you make electrical contact to that, then it knows it's made contact. So I'm assuming that goes to the probe connection on the control board. So with that, let us see what happens if I just turn it on, since I now at least have a little controller here. So if I can find the power switch. Made a little bit of noise, so something fired up. And, oh, great rastering through the display here. Looks fine visually, but so control. I guess that's got a certain step size, so. I don't know if there's a home option on it. Turns the spindle on and off. So it gives me X, Y. Oh, the Z controls. Z controls are over here. I was trying to figure out. So you can see that rastering badly, but that's not good. Oh, that's because we were at the limit. And now nothing's going anywhere. Let's see if I reset. Something stalled and completely messed everything up. So it would appear that this functions. So time to hook it up to a computer and install the software and see if I can make something. Alright, so I have me a scrap of wood installed, and I have one of the little V-bits. I'm not sure exactly how well that will do, but it's on there. And I have mounted this up. I didn't want to scratch up my nice new tables, so I'm not overly impressed with these. I mean, they're simple for what they are and easy to replace if you need to, but they could be a little better. And the grid's reasonable for mounting things, but I did find that I was going to put this horizontal and found that these were kind of too far apart, or too close together, whichever way you want to think about it. Now, I've went and edited my image in another piece of software and have pulled the G-code in. I have homed the work coordinates by going and moving it to the desired location and calling that 0, 0. And that should be that point. And we are essentially ready to go. So let's see, where is the button to start send? All right, let's give it a shot. Okay, that's running without the spinning. Why don't we turn the turn the rotor on. For some reason, it doesn't want to run the spindle. And I don't quite understand that. It is carving with that nice sharp tip, but that's not what I intended to be doing. Okay, so after stopping the test, I'm going to turn the spindle on manually, and now tell it to set the G code. I'm not totally sure about these tips. Looking like my O. Probably cutting deeper than I should be. Oh, it's a star. Yeah, the particular software is trying to just cut along the lines of the line art as opposed to the solid parts. And I may still be too close to the top. I think it's gonna be great if it would do the outline first. Looks like that's gonna be the last. Yeah, we're going to be off the board. Let me simplify this and try again. Great, let's mill my phone. Say what you will, this thing actually moves a decent amount of air. All right, well that's enough for a first test. Okay, so I decided to come back and use a nicer piece of wood, and I set it to only go a couple of steps deep. in the software, so that sped things up. And essentially, there you have the logo. Not great, but okay if I can figure out a way to actually have it do what I want, which is to, for example, machine this area out and make some of the lines solid. Then we'll see what happens. But overall, it did okay. I had to actually lower the motor down to deal with this thin material, though. And the other interesting thing is that, of course, the G-code didn't have anything to start the cut originally. It also didn't have anything to stop it, so I had to manually stop the motor. I had to actually abort the test, which stopped the motor, or abort the run. So with that, I'm going to call it quits, and I hope you enjoyed this unboxing and assembly and testing of this Genmitsu 3020 Pro Max. Thanks. Have a good day.